Welcome to our session on the audit of algorithms. My name is Iuliana Sandu, and I'm going to present this session together with my colleague, Otto Koppius. We are very happy to present during the Erasmus Data Summit. This is a topic in which we do research, so it's a topic that we care about a lot, the audit of algorithms. I would like to start the session by thinking about an example. Let's think about you going to the doctor for a checkup, and the doctor makes some tests and comes up with an output for you, which says Tapanuli fever 17.88, risk high. You ask the doctor, what's this number? What's 17.88? What does it mean? And the doctor tells you that our new AI system placed together all the results from your test and came up with this number. And this number tells you that you are at a high risk of getting this Tapanuli fever. The bad part is that it can be deadly. The good part is that you can get a medicine, a preventive medicine. But this preventive medicine can have some side effects like nausea or irritation. And then you leave the doctor's office and you wonder whether you should take the medicine or not. You go home actually and you Google, you try to understand what an algorithm is. And then you Google and you see that an algorithm is a word used by programmers when they do not want to explain what they did. So this leads itself to understand that an algorithm is a complex thing. But despite algorithms being complex, we still trust them. So look at this situation depicted in this slide, where we see a tunnel where cars are speeding, and then we see also some tourists on bikes alongside the cars. This is a case where the people trusted the technology, trusted the Apple navigation system, that this system would send them to the right place. But then technology and the algorithm failed here. Is the navigation system task the only one where algorithms fail? Well, actually, it turns out that it's not. We can see here an example in the financial industry where people apply for an Apple card. And in this case, a couple, David Hansen, together with his wife, Jamie, applied for the Apple card. And they had the same objective type of characteristics. So they had the same property, no previous late payments, no other debt. So the same characteristics, except that David is a man and Jamie is a woman. And Jamie received a much lower credit limit for her Apple card. Then David took this problem to Twitter, arguing that the Apple card has a sexist algorithm behind it. So this was a situation when the algorithm failed again, despite the fact that Apple representatives said that we specifically didn't use gender in our algorithm. We do not want to discriminate based on gender, but actually that happened.
So another example of where algorithms can give some strange results, and I put up an image search for Google when I search for the word data scientist. And if you have a look at the results, and this was a year ago, so I hope by now it's better, but you'll probably see something striking. Namely, almost all the pictures are of males. Whereas if I think of the graduates that I deliver in our data science program, you know, it's more than, it's around 60-40 male-female, and it's not really almost exclusively male, the way it says here. So if these images that Google thinks data scientist represents a male are primarily then used to, for instance, determine the relevance of data science education and job ads, primarily targeting males and not so much females, then that bias is reproduced. In other words, another issue is that if there's biases in the training data, the algorithm will reproduce itself. It's not going to automatically correct itself. And actually on the next slide, we can see some even trickier issues with these biases. And this was an algorithm that seemed fairly, let's say, uncontroversial, or at least a standard application where hospitals use to allocate their limited budget. and they would use an algorithm to predict a risk score for patients. In other words, which patients are likely to receive, to need complex care and which are likely to receive, to need simple care. Now, like in the Apple Card situation that Iuliana described, they were very careful to not include race in the algorithm because it's illegal to discriminate care based on race. However, if when they tested it, they said, okay, yes, both Black people and white people got the same cost at an equal risk score. So you would think that's unbiased. However, when they looked a little bit further, they saw that Black people were sicker than white people at the same risk score. Or to put it in a different way, when two people were equally sick, they would get different care because the Black person would receive a lower risk score and the white person would receive a higher risk score for the same underlying health. So in that sense, the algorithm was biased. And there was actually, it wasn't necessarily an issue in the algorithm itself, but an issue in, let's say, how Black people use healthcare in the United States for complex societal reasons. And that meant that those biases got reproduced in the algorithm. And the existing Black-white disparity that was already existing in the healthcare system got reproduced by the algorithm. So how do you solve that? Well, the researchers who studied this said, okay, well, instead of predicting total healthcare costs, we can also try to predict the avoidable healthcare costs, so emergency visits or overall health. And all of these are, you know, from a healthcare management point of view, are perfectly justifiable. What are you trying to predict? And they could develop models that were equally accurate. However, the racial bias in that first variant, where you try to predict total cost, was twice as large if you would use one of the other two variants, the avoidable cost or predicting health irrespective of cost. In other words, even the choice of what you're trying to predict can matter a great deal for the kind of bias that is and is not in your algorithm, or that will get exacerbated by your algorithm or not. Now, an important thing to keep in mind with all of these, that it's tempting to think of this as a data problem, but it's more than a data problem. It's not just a software problem, it's more. It's not just a user problem that the user doesn't know. It's not an organizational problem. It's all of these, and all of these stakeholders need to work together. Similarly, it's not just something that you do only during the design where you test it, that's necessary, but it's more. It's also something that you have to do during the operational stage. You have to look at both error prevention as well as error detection and error management. All three phases need to be in there. And that means that the responsible use of algorithms is an ongoing process. And for that ongoing process, we have developed a framework.
I'm going to take over here because this framework comes from my line of research, which is financial auditing. And we borrowed from this financial auditing framework three important aspects. When a financial auditor performs an audit, they give an opinion with respect to a composite assertion, to a global assertion. So they give an opinion with respect to whether the company represents fairly its business events in its financial statements. Because this is a very general assertion, a general statement, auditors break down this assertion into small workable assertions that they can actually collect evidence on. So once they split this assertion into workable assertions, they collect evidence on these assertions, and evidence can be from interviews to statistical analysis. So it can have various degrees of complexity, this evidence. What we did in our research is that we came up with a composite assertion for algorithms. And in our case, for the audit of algorithms, the assertion that the owner of the algorithm makes, the manager, let's say, is the following. The algorithm serves the organizational purpose for which it has been deployed, so it does what it's supposed to do, without causing unexpected consequences to stakeholders. And this unexpected consequences is something that is very important, because what happened also in the Apple Card situation is that the company did not expect this consequence. So what an audit does, it flashes out all the issues that can go wrong with an algorithm. And of course, in order to consider all the issues that can go wrong with an algorithm, multiple stakeholders that are impacted by the algorithms have to be taken into account. We took into account all these stakeholders and designed this framework for the audit of algorithms. This is the comprehensive framework that takes a holistic view on an algorithm. It has an overarching composite assertion, which is the one that I mentioned before, that the algorithm does what it's supposed to do without unexpected consequences. And then we designed workable assertions for the entire ecosystem of an algorithm. It's not only about the algorithm or the data, as Otto mentioned, it's about the users as well, because the users give you more data. So it's an entire cycle between user, data, and algorithm that needs to be taken into account. We're going to walk through very few of these assertions to show you how they would work in practice. And then we're going to start with an example.
So the example that we're going to use is from a context that most of you will be familiar with, hiring. And we're taking a hypothetical example of a software company, although it's based on actual research of these kind of algorithmic hiring systems. And the software company decided, okay, we're getting so many applicants, we need some help in speeding up this process. So we've developed a text mining application so that the CVs that get submitted to our company, we automatically extract the relevant components from education, experience, maybe grades, etc. And then we use a k-nearest neighbor algorithm where we compare the current applicant to past applicants to see how similar are they to some of these past applicants, or the most similar applicants, and were these most similar applicants hired or not. And based on that, we give a likelihood for this new candidate. How likely is he or she to get hired? And in other words, will we invite him or her to the next phase of the hiring procedure? Now, of course, this is a sensitive context. So Sophie wants to be a responsible company and says, well, we want to make sure that we treat our applicants fairly, because, we want to preserve our reputation, and maybe somebody that will not apply to us now may get through in the future. So we want to be responsible and transparent and open about this. So how would we audit an algorithm like this? As Iuliana explained, in the overall framework has a number of categories. We're going to go through one assertion in each of these categories. But one of the assertions that is often forgotten, or at least kind of, walked over a bit, is the purpose clarity. What is this algorithm supposed to do? And many of the companies that, for instance, that we give our data to, when we say we give your data to you to improve your services. So if Sophie had written, we use the algorithm to optimize our services, that would be very vague. That would be difficult to understand, and a lot of things can fall under that umbrella. So that's not really a good auditable purpose. So we want to say, for instance, we use the algorithm to assist recruiters making decisions based on CV on who to invite for an interview. So then it's clear what the actual decision is. And the goal of this purpose clarity assertion is that you can always point to a specific decision maker for a specific decision in the organization. And then you know where the process is and how it should be audited by which stakeholders. Iuliana will continue with another one.
Well, if we go in the control area, in our framework, we picked monitoring, because monitoring, it's forgotten. Also, again, like Otto mentioned, companies deploy an algorithm and then they don't monitor it anymore. And the auditor can go to the company and ask, what sort of performance metrics do you track with respect to this algorithm? How do you monitor it? And these performance metrics can be the classical predictive accuracy for these predictive models, or they can be more advanced performance metrics, like what if this hiring company would develop a special error rate where they would track the candidates that got rejected by them. And they would track these candidates to see if these candidates are very successful with other companies. Then if they realize that a rejected candidate is very successful somewhere else, then they may adapt their algorithm. They may give feedback to the algorithm so that the algorithm improves.
Now, if we go to an assertion in the data category, one of the other aspects that, especially in recent years, has come very much into play is how, where does your data come from? Do you know the data provenance? And this is particularly becoming relevant now that organizations, sometimes they develop their own algorithm based on their own training data, but increasingly, and especially in natural language processing, or also some others, like some of the facial recognition algorithms or some of the healthcare algorithms, companies rely on off-the-shelf algorithms that are pre-trained on some external data source. And that means that not only is the algorithm itself a bit of a black box, it also means that the source of data on which it was trained can become a bit of a black box. So you don't know how accurate, how valid the training data was. You're kind of getting the algorithm off the shelf. But even if you're developing your own data algorithm, you still have to be sure that where is my data coming from? If I'm scraping social media data to build a customer profile, how reliable is my Facebook or my Twitter or my Instagram data? You also need to do data quality checks, like are there no, let's say, hidden words in there? People have been known to fool CVs by putting words like Oxford and Cambridge in invisible text in there so that the algorithms get fooled. So the reliable data provenance is a key issue also that needs to be addressed with, that goes beyond just testing the algorithm itself.
And the examples that we gave before with respect to the Apple Card and the health example algorithm in the United States, they all had the disproportionate negative effect on a specific group of people. And in this case is the Black population. Therefore, the framework includes one workable assertion that is connected to this disparate impact. So the auditor needs to understand whether the algorithm has a disproportionate effect on a specific group of people. The evidence in this case can be collected through a statistical analysis where the auditor looks at how the algorithm affects different groups of people in the sample that they work with. So this is also a very important workable assertion, and it's included in this holistic framework that we designed. And when we look at this period that we've all gone through, we all experience technology going bad. So technology not working as it's supposed to work. And also algorithms do not work all the time as they should. And humans need to step in and solve the problem. And that's why we think that it's the responsibility of all of us to understand algorithms. This framework that we designed, it's a framework and it's holistic because there's not a single test that you can run and say that this algorithm is okay. You cannot just look at its predictive accuracy and say it works. You need to consider all stakeholders in this holistic framework. And also, organizations will need to do that because the public doesn't accept this anymore. The public does not accept the justification that when an algorithm doesn't work as proper as it should, the justification is that it's just the algorithm. The society does not accept this anymore. So I would like to thank you for listening to us and to listen to to find out about this framework that we came up with. And now I'm gonna stop the presentation for the Q&A session.
All right, well, thank you very much, Iuliana and Otto, for this presentation. I'll dive right in with the first question. It is about extrapolation, and it asks, how do you determine that an algorithm is also good at extrapolation? Because most of the time, it is only able to give a correct decision within the provided training data, i.e. interpolation. So what are the criteria for good extrapolation of algorithms?
I can jump in on that. The short answer is there are none. There are no criteria for correct extrapolation, at least no ex ante criteria. There are a lot of things you can do through testing with, a validation set, testing set. But I think the most important part comes with the monitoring assertion that Iuliana described. Especially early on in the deployment of the algorithm, you need to keep close track of the performance, because you can do a lot of things in the design stage, like developing a representative data set, like for instance, Franz Müller from Alde said in his talk. But ultimately, the real answer to the extrapolation question comes during the deployment. And you have to keep a close eye on your deployment and adapt where necessary.
I see. Our second question touches upon the stakeholders, which may be impacted by potentially badly implemented or designed algorithms. The question asks, which player is responsible to make sure that all stakeholders are sufficiently involved in preventing undesired outcomes?
When it comes to the stakeholders, again, borrowing from the financial auditing, that's an entire history there, where the person responsible was the management. The management was the one that had to own this responsible use of the algorithm. And we went with financial auditing through a series of iterations when management didn't want to have this responsibility. But in the end, a lot of laws and regulations were issued that made the management responsible for the responsible use of AI. And I think this will happen also in the case of algorithms, that the owner of the algorithm, the company using this algorithm will bear most of the responsibility, and they will make the assertions. They will state that my algorithm functions properly.
Thank you.
There's a particular risk when dealing with multiple stakeholders within an algorithm context, because take, for instance, the data provenance assertion that I described. A software engineer who actually builds the algorithm and puts it into production might say, okay, the data provenance, that's the responsible of the data scientist to say, okay, I need this data source. But the data scientist may say, okay, it's the responsibility of the software engineer to, for instance, correctly program the API to get the data from this external source. So there's a risk of this shared responsibility that then ends up falling in the middle. And that's a problem that we haven't solved yet, because there's a big risk that everybody is looking to somebody else to solve this, which is known as the problem of many hands.
Yeah, to what extent would you say especially in the financial sector, to what extent are the companies equipped to audit these algorithms because of this responsibility that falls on their hands? But
sorry.
Well, how?
Yeah.
Okay. How well equipped are these financial auditing companies to deal with biased algorithms?
Well, we collaborate with other companies in our research with KPMG, EY. We work with them, and we see that these companies, these service providers are getting more and more equipped to audit algorithms. So there is a market developing for the audit of algorithms. And then the banks will go to these companies for an audit of an algorithm, probably.
And just one thing to add is that companies are, even non-financial companies, they are used to monitoring their business processes. So it's not a totally foreign concept. It's just that part of the process is now being done by an algorithm. So in that sense, yes, it's difficult, but at the same time, it's not completely foreign even to non-financial or non-high-tech companies.
Well, thank you for this insight. This rounds up the Q&A session. I apologize for those of you whose questions could not be answered due to time constraints. And thank you very much, Otto and Iuliana.